Hi, hello, welcome to today's lecture. In this lecture, we are going to learn one of the important topic, and that is Cannizaro reaction. Okay, so bring all your juice together to learn important concept, and without delaying, let's get into the topic. So put the heading Cannizaro reaction. Okay, so firstly, we have to look into the conditions. Conditions are very important for a reaction. Coming to the first condition, there should not be alpha hydrogen. And coming to the second condition, the base should be concentrated. Okay, so what are the alpha hydrogens? Okay, if I take a functional group, so the next carbon to that functional group we call alpha, and the next carbon to that one we call beta. Understood, right? Now hydrogens on the alpha carbon, we call them as alpha hydrogens. Okay, for Cannizaro reaction there should not be alpha hydrogens. Okay, coming to the types, we have two types, inter-Cannizaro and intra-Cannizaro. Okay, so firstly we will focus on inter-Cannizaro reaction. So without delaying, put the heading inter-Cannizaro. So take a pen and paper and try to practice along with me. Okay, so put the heading inter-Cannizaro reaction. Inter-Cannizaro is again of two types. Okay, first one is self-Cannizaro and the next one is cross-Cannizaro. Okay, firstly we will learn self-Cannizaro. Okay, so under self-Cannizaro I am taking one example, okay, which is very familiar to us. So that is formaldehyde. Now I am taking concentrated base. Okay, now what are the products that we get here? So you have to remember, one get oxidized, the other get reduced. So the same molecule get oxidized and the same molecule get reduced, and we got formate and we got methanol. Okay, now let us understand the mechanism so that we can understand how we got these products. Okay, so mechanism is very important. Once you are expert in the mechanism, then no one can stop you solving the questions from this particular concept. Okay, so coming to the first step, attack of nucleophile. Attack of nucleophile. So I am taking one of the molecule like this. Now base comes and attack on the carbon, the pi electrons shifts like that. Now why we mentioned we should not require alpha hydrogens? Okay, if we have alpha hydrogens, now base come and abstract hydrogen, which leads to the aldol condensation, and which we don't require, right? Here we need Cannizaro reaction. If we have alpha hydrogen, that leads to aldol condensation. Okay, so look at the product. Look at the product, what we got here. Okay, now coming to second step, hydrate transfer. Taking the same one here. Now the negative charge on oxygen get involved in the conjugation. Okay, so if hydroxide, among these hydroxide ion is a better leaving group. If it is leaving, we'll get the same one, no difference, right? So here hydrogen will take out the electrons. Hydrogen will take out the electrons and attack on another molecule, and pi electrons shift like this. Understood, right? Now remove the hydrogen and make the double bond between oxygen. So what are the products we are getting? HCOOH, formic acid, along with this methoxide ion we got. Okay, that's the second step. Coming to the final step, which is proton transfer. So take the same one. Taking the same one. Now here hydrate, H minus is a hydrate, H plus is a proton. Okay, now oxygen pulls the electrons towards itself. Now H plus, this proton gets transferred here. Now you may get doubt why proton is getting transferred here. So for that we need to look into the structure. Now once proton leaves, oxygen gets the negative charge. Okay, that negative charge will be involved in the conjugation, which is stable. But coming to the negative charge on this oxygen is not stable when compared to this molecule. Here in this molecule, negative charge is supported by conjugation, whereas in this molecule it is not supported by any conjugation. Okay, this is how we can write the product in long procedure. Okay, by understanding the mechanism. Now we will learn how to write the product within 5 to 10 seconds. Okay, so put the heading shortcut. Writing the product within 5 to 10 seconds. So taking two same formaldehyde molecules. Now what we have to do here, simply look at here, simply remove hydrogen, add oxygen negative to one molecule. So one product came. So what we have to do, remove hydrogen, add oxygen negative, one product done. Now to the second molecule, what we have to do, add one hydrogen on the carbon, the other hydrogen on the oxygen. That's it. Understood, right? How to write? It takes maximum 5 to 10 seconds. Okay. So this is how we can write product in 5 to 10 seconds. Okay. Now let us understand the important points. Why do we need to? Because yet we didn't understand the mechanism 100%. So by going through all these points, we understand the mechanism 100%. Okay, so coming to the first point, it is redox reaction. Okay, the same reaction, one is going under oxidation, the other undergoing reduction. So we call it as a redox. Now what do you mean by disproportionation? If the same molecule undergoes oxidation as well as reduction, we call it as a disproportionation. Okay, coming to the second point, migration of hydride is a rate determining step. So here, this is a rate determining step. This step determines the entire reaction. Okay, coming to the next point, which is very important for solving the questions. Okay, so the more electropositive carbon get oxidized. If you observe clearly, as I mentioned, one get oxidized, the other get reduced. Which one get oxidized and which one get reduced? The carbon with a more positive charge, that get oxidized, because base will be attacking on the carbon which is having the more positive charge, right? Here base has to come and attack, no? Whenever there is a more positive charge on the carbon, the base attacks easily. Okay, one get oxidized and the other get reduced. Coming to the fourth point, isotopic effect is observed. Okay, we will understand this particular point by taking one example. And coming to the next 2 points, low concentration molecularity is 2 and order is 3. It's 3. Coming to the high concentration, molecularity is 2, order is 4. Okay. Now coming to the last point, which is also very important, there is no formation of carbon-carbon bond. Okay. Now why I mentioned very important. So in the question, he will be asking in the question, which among the following 4 reactions carbon-carbon bond is not formed? So in one of the option, Cannizaro reaction will be mentioned. If you know about the Cannizaro reaction, you have 4 marks in your pocket. Okay, so I feel you understand the mechanism 100%. Okay, now let us take one example for isotopic effect and try to understand what does mean. Okay, so here I am taking, look at the molecule what I am taking here. So this is the condition. So we have protium and deuterium in the molecule. Okay, now what we have to do, simply in one of the molecule remove hydrogen, add oxygen negative, and in other molecule add one hydrogen on the carbon, the other hydrogen on the oxygen. But the question is, we have protium and deuterium, which one get transferred here? If you observe carefully, carbon deuterium bond is more strong when compared to carbon hydrogen bond. So breaking carbon hydrogen bond is very easy. So hydride get transferred here. So what you have to do, simply take out hydrogen from one molecule, add oxygen negative, and the other molecule simply add hydrogen on the carbon, the other hydrogen on the oxygen. That's it. So this is how we can write product within 5 to 10 seconds. Okay, now we are getting into the previous year asked questions so that you will get an idea how we get questions. Okay, so put the heading practice. Now we are going to practice some previous asked questions. Okay, so try to be too Josh in order to solve the questions. Do that thing which excites you. Okay, if you are excited, then you can learn anything very easy. Okay, so it's taking time to rub. So put the heading practice. So take pen and paper, practice along with me so that we can become expert in the Cannizaro reaction. Okay, so the first question which is asked in 2024 JEE Mains. So look at the molecule here. Chlorobenzaldehyde, and the condition is given 50% KOH. So instead of a concentrated base, they can mention 50% base. Also they can mention base in alcohol. These three conditions result into Cannizaro reaction. Okay, now take 5 to 10 seconds of time and try to solve the product. It's easy. One get oxidized, the other get reduced. So I hope you are done. So let me make products here. The other one will be reduced. One get oxidized, the other get reduced, as much as easy. Okay, now let us solve one more question which is asked in 2021 JEE Mains. So look at the question, look at the molecule given in the question. So here KOH given in alcohol. Try to solve this question. Maximum it takes 5 to 10 seconds. Okay, so take pen and paper and put pen and paper. Okay, simple. One get oxidized, the other get reduced, and don't touch alcohol. Okay, so one is getting oxidized, the other getting reduced. Very easy, right? So far we learned self Cannizaro reaction. Now we are going to learn cross. We are going to learn cross Cannizaro. Put the heading cross Cannizaro. So let me take the question which is asked in 2019 JEE Mains. Okay, so what is the question asked here? So one molecule is given formaldehyde, the other molecule is given benzaldehyde. So what is the cross Cannizaro? The reaction between Cannizaro reaction between different molecules. In self we will be taking same molecule, in cross we will be taking different molecules. Now base is given concentrated sodium hydroxide. Now here the question is which one get oxidized, which one get reduced. We need to write the products. So you get a doubt which one get oxidized, which one get reduced. I think we learned third point in the important points. What is that? More electropositive carbon get oxidized. Now if you look at the benzaldehyde, because of conjugation, carbon is not getting that much positive charge when compared to the formaldehyde. So formaldehyde get oxidized, formaldehyde get oxidized, and benzaldehyde get reduced. That's it. Okay, this is the cross. We are done with the self and cross. Okay, now let's get into the intra Cannizaro. Put the heading intra Cannizaro. Okay, in the intra Cannizaro we'll be having only one molecule and we'll be having two carbonyl groups on the same molecule. Okay, one get oxidized, the other get reduced. Okay, let me take one example. So I'm taking this molecule. So try to solve this question. So I'm giving KOH in alcohol medium. So try to solve the question. So which carbon get oxidized, which carbon get reduced? Take 5 to 10 seconds of time. Put the pen on paper. Okay, so if you look at here, we have the chlorine which shows minus I effect. Because of minus I effect, this carbon will be having more positive charge when compared to that carbon. Okay, so here this carbon get oxidized, this carbon get reduced. Okay, so look at the product. So this is the intra Cannizaro. Okay, so we are done with the self, cross and intra. Okay, let me differentiate you these three. Okay, so the first one is self Cannizaro. In the self Cannizaro, we'll be taking two same molecule, one get oxidized, the other get reduced. Okay, now coming to the cross, we'll be having two different molecules. Say in self we'll be having two same molecules, in cross we'll be having two different molecules. The one with the more electropositive carbon get oxidized, the other one get reduced. Okay, coming to the intra Cannizaro, we'll be having only one molecule. In that one molecule, two carbonyl groups are present. The one which is having more positive charge, that get oxidized, the other get reduced. Okay, so this is self, cross and intra. Okay, let me take one limitation over here. So look at the molecule which I am giving here. If you look at this molecule does not give Cannizaro reaction. Why this molecule is not giving Cannizaro reaction? It's because lack of positive charge on carbon. Okay, now if you observe clearly here, this lone pair of electron involves in the conjugation. This pi electrons shifts here and this pi electron shifts here, and here pi electron shifts to oxygen. If you observe structure here, look at the structure here. So look at this. Here carbon is getting double bond. Here we don't have the positive charge on the carbon, and because of that base cannot attack on the carbon, so which does not give Cannizaro reaction. Okay, so this is about self, cross, intra Cannizaro and limitation also. Okay, so I hope you got the concept, and I hope you can do any question related to Cannizaro reaction. Okay, so let me give you one homework question. So try to solve this question. By solving this question, you will try to understand whether you got command over this concept or not. So what is the molecule I'm giving? I'm giving cross Cannizaro. Okay, so this is cross Cannizaro. So this gives Cannizaro reaction. These two molecules gives Cannizaro reaction. And the thing you have to do is which one get oxidized. You have to find out which one get oxidized and which one get reduced. Okay. So I hope you understand the concept very clearly. So this is from this lecture. We will be meeting in the next lecture. Until then, take care. Bye bye.